AMC 2004, Problem 5. A set of 3 points is randomly chosen from the grid shown, and each 3 point has the same probability of being chosen. And we're trying to find the probability that the points lie on the straight line. So in this case, we don't really need to consider complementary counting. We can just go directly because there are more cases where they're in a line than they're not. And since we're given that each 3 point set has the same probability, that means that they're all equally likely to be chosen for any set of 3 points. So we can exclude biases. So given this, how do we find it? Well, the probability of anything will be the the total number of solutions and the total number of possibilities. So if we want to find the total number of possibilities, how many ways can we pick 3 points from the 9 points shown? Well, that's obviously a combination of 3 pick 9. The reason why for this is because ABC is the same thing as CBA. We don't want to say that they're independent of each other because if I pick this point, and this point, it is the same thing if I pick it in the reverse order. So I want to make sure that I do not overcount possibilities that are the same. So therefore, we use combination of the 9 points. We pick 3 points that we want to be uh, non non-specific. So if the combination of 3 pick 9, that would be the same thing as 9 factorial over 3 factorial and 6 factorial. So this would be the same thing as 9 times 8 times 7 over 3 times 2, which this becomes 3, this becomes 4. So this is 12 times 7 is 84. So the denominator will be 84. But what about the numerator, the number of solutions? Well, we can just simply draw it out again and deduce for ourselves how many of the 3 sets of points are in a straight line. Well, this is 1, 2, 3. For the number of rows and the number of columns, they're all going to correspond to a set of points that are in the straight line. So we have 3 rows and 3 columns. And then we have to consider the diagonals, which is this diagonal and this diagonal. So therefore, we must add 2 again. And this will be the total number of lines or the set of 3 points that are in a straight line. If you do not believe me, you can redo it by yourself and you can convince yourself that this is true. So if this is the total number of solutions, then we simply put 8 on top of the denominator and we're done. We just need to simplify and we're over. So this is equal to 2 over 21, divide 4 on both sides. And this brings us to answer choice C, and we're done.